what volume is occupied by a single molecule. The molecules of a gas move in straight lines. They move in all pause. Relaxation time is 10 power minus 9 seconds. And finally, that is what we call the law of equipartition of energy. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. A new chapter, a new session. The chapter that I discuss in my today's session is Kinetic Theory of Gas. Using all those topics, all those concepts that we learned in thermal properties as well as thermodynamics. Today, we try to understand a very beautiful chapter, what we call as Kinetic Theory of Gas. Now, what is the objective of studying this chapter? Main aim of understanding this chapter, the basic understanding of this chapter leads us to understand the nature of a gas. Sir, ಇದನ್ನಾಗಲೇ ನಾವು ಗ್ಯಾಸ್ ಲಾಸ್ನಲ್ಲಿ ಓದಿದ್ದೀವಲ್ವಾ ಸರ್? Yes. But when I say nature here, I am trying to mean that we understand the concepts related between kinetic energy and temperature of a system. The whole show of understanding here is to relate the kinetic energy of a gas with temperature. Right? When we studied thermal properties, I told temperature is an internal function of a system. Why is it an internal function? That is what I understand in today's discussion. We will understand the postulates of kinetic theory, kinetic interpretation of temperature, how kinetic energy is distributed among the molecules of a gas, and finally that is what we call the law of equipartition of energy. So now we start discussing about the postulates of kinetic theory, which is a very important 3-mark question asked. To write the postulates or the description of a gas according to kinetic theory. The first law says that, or the first postulate says that, a gas consists of large number of molecules. A gas is a collection of large number of molecules. A gas is made up of small particles, large collection of molecules which are perfectly elastic, identical, and solid spheres. The very first postulate says the molecules of a gas are elastic in nature, perfectly elastic, identical. In what sense they are identical? Meaning to say they have got the same size. When I say identical, it means they have the same size, perfectly elastic, identical, solid spheres. So we can consider a gas to be like a ping pong ball, table tennis ball, which is perfectly elastic. All the molecules have the same size and they are solid spheres. And further it says the volume occupied by a single molecule is negligible when compared to the volume of the entire gas. Alva, what space, what volume is occupied by a single molecule is very much negligible when compared to the volume of the entire gas. Therefore, the first postulate of kinetic theory says when we speak about a gas, it is a collection of large number of molecules. What is the nature of those molecules? They are perfectly elastic, identical, which means to say made up of the same size, and they are solid spheres. And whatever volume a single molecule occupies is very negligible, very small when compared to the molecules of the entire gas. Second one, the molecules of a gas move in a straight line. We call this as rectilinear motion, and they move randomly in all possible directions within the container, throughout the volume, in whatever directions possible. They move in a straight line. Now, this is important, very important. Consequence of the motion of the molecules of the gas. I told, given any medium in a container, the molecules of a gas move in straight lines. They move in all possible directions. In whatever volume is available, they move randomly. And because of that random motion, they may collide with the other molecules or the walls of the container. Alva, since the molecules are exhibiting random motion, remember, a gas is a collection of large number of molecules. These molecules move randomly in the container, and what is the result? They will colloid with the other molecule or with the walls of that container. And the time interval for two successive collisions. See, large number of molecules. This molecule initially strikes molecule 1, then successively it strikes molecule 2. The time interval for two successive collisions is what we call relaxation time. Very important definition for 1 mark. Relaxation time. Time taken by a molecule to exhibit two successive collisions. What is it called? Relaxation time. And it is in the order of nanoseconds. Relaxation time is 10 power minus 9 seconds. So here, if you understand, since the molecules move randomly, they colloid with each other. Also possibility that they colloid with the walls of the container. The time for two successive collisions is called relaxation time and is in the order of 10 power minus 9 seconds. Now, very important, this is the key point. The collision between two molecules is elastic. In the first postulate, when I described the nature of molecules, I told they are elastic in nature. The collision between two molecules is elastic. What do you mean by elastic collision? Which means both kinetic energy and the momentum of the system is conserved. When two molecules colloid with each other, they don't lose kinetic energy. They don't lose momentum, may be transformed to some other form. But kinetic energy and momentum of the system is conserved. Such type of a collision is called elastic collision. Therefore, we say the collision between two molecules is elastic. Why? Here there is no loss of kinetic energy, no loss of momentum, and hence the collision is elastic in nature. And the last one, the distance traveled by a molecule during successive collisions is called free path, and the average distance traveled is called mean free path. Whatever distance the molecule covers during collisions, they are called free paths, and the average distance is what is called mean free path. And this is the postulates of kinetic theory. What is the nature of molecules? They are elastic, they are identical, same in size, they are solid spheres. They move in a straight line, they move randomly, in all possible directions, because of which they may collide with each other or with the walls of the container. Time taken for two successive collisions is called relaxation time. The nature of collision is elastic, where both kinetic energy and momentum is conserved. And it also spoke about free path and mean free path. Now, the collision between two molecules is elastic, no doubt, where we clearly told momentum and kinetic energy is conserved. But what happens to the velocity? Very clearly, velocity of the molecules changes after collision. So we told collision between two molecules is elastic, absolutely no doubt. Kinetic energy is conserved, momentum is conserved, but what happens to velocity? Velocity of the molecules change after collision. Now, we will take up the concept of mean free path. I told the molecules of a gas move randomly in all possible directions within the volume of the container. In all possible directions, the molecules move, because of which probability of collision with other molecules and the walls of the container. Now, during these collisions, the molecules will certainly travel some distance. And I cannot say that every single collision it defines, it travels the same distance. During first collision, distance traveled by it may be small. During the last collision, it might have traveled a longer distance. So I cannot conclude saying that during every collision defined, the distance traveled is constant. Then how do I calculate that distance? I will consider the average distance, mean distance traveled by the molecule during all such collisions. And this average distance is called mean free path or average free path. It is the average distance traveled by a gas molecule during n successive collisions it defines, and it is given by the expression lambda equals kt divided by root 2 pi d square into p, where k is called Boltzmann constant, T absolute temperature, D diameter of the molecule, and P is pressure. Therefore, what is the dependence of lambda, mean free path, on these parameters? Lambda is directly proportional to absolute temperature. Increase the temperature, kinetic energy of the gas molecules increase. They have more energy. They can travel long distances. So increase the temperature, mean free path also increases. Lambda is inversely proportional to diameter. If I'm a heavy stout, I cannot easily cover longer distances. If the molecule has a larger diameter, the mean free path covered is less. So lambda is inversely proportional to the diameter and inversely proportional to pressure. So dear students, today we studied the postulates of kinetic theory, concept of mean free path and the given expression. Please to understand the order of mean free path for any gas molecule is 10 power minus 7 meter. In my next session, again I come up with a beautiful topic called kinetic interpretation of temperature, degrees of freedom, and law of equipartition of energy. Until then, revise the session. Enjoy the day. Thank you.